And ABE looks like I went from, I did nothing, then I did the long side, short side, so I have to go nothing, long side, short side, so that'd be CDE. But most of us are pretty good at that at this stage. All right, Owen, does that answer your question? All right, what else we got? Yeah. 11. 11, I'd immediately go, okay, we do have vertical angles. If we don't see that by now, guys, I don't know what we're doing. Vertical angles are those angles that are straight across. I see vertical angles there. That should be just in your sleep knowing what vertical angles are. That means I'm looking at side angle side if it works. To be side angle side, I have to go small over small equals long over long. So look at that 87 and 95. Well, 87 is the small. 95 is the large. Look at the other one. 68 is the small. 72 is the large. I'll call this big triangle the top. Large to large over small to small, that'd be 95 over 72 equals 87 over 68. Does that work? Is that a true statement or is that a false statement? False. That is false. If you plug those in your calculators, and you could check that on your own, that is false, which means they are not similar. Those are not similar triangles. So I guess we can put the old not similar. It was close, though. I had the. It started looking like it was going to because we did have those vertical angles. It looked like it could have been side angle side, but it turned out it was a false statement, so it doesn't work. All right, what else we got? All right. 6. All right, 6, we have 96, 80, 64. So I can't use angles. They don't say anything about angles, so that means I need to do large to large, medium to medium, small to small. So we just go across the board and go, okay, my 96, that's my large side. My medium side looks like 80. And my small side, let's use a triangle, would be this one. Then we'll do the exact same thing over here. My large side is 54. I used a box on the other one. My medium one is this 45. I seem to have circled it on the other one. And then I put a triangle along my small one. Do we need both things? Do we need geometric and the letters? No. Remember, this is for you. There's no way I can take off points because these aren't official math marks. These are just Mr. Pabian's class, keep things organized kind of thing. I do find if you pick a method, it makes these a lot easier because now I see large to large, medium to medium, small to small. I'm going to call this one my top one just because it's the first one I see. And I go large to large, that would have to be 96 over 54 equals medium to medium would be 80 over 45. And small to small would be 64 over 36. If that statement is true, it'll be side, side, side. If any of those are false, it would be not similar. Are all those statements true? It should turn out yes. I believe memory-wise these all work, so this would be true. Whether you simplify the fractions or you just plug in your calculator, so this would be side, 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 similarity. We should also have a triangle similarity statement as well. Yes? Number 7. Number 7, I'm going to note that we have parallel lines. That's going to be our big thing, our parallel lines. Yeah? Yeah. So we do have parallel lines. Let's highlight those. I have a parallel line here, and I have a parallel line here. So the first thing I might notice is this transversal right here. Well, that transversal creates corresponding angles right there. So we should be able to go ahead and say that those two things are in fact similar. So I'm not similar, I mean congruent. All right, then I look at these parallel lines and I'm like, okay, I need another pair of angles if I want to make this a similar statement. So I look at the other transversal. My other transversal, let's color it in purple, is this line here. Well, the only thing it creates are alternate interior angles. So I could have on here wrote like dun, dun, burn, burn. Is that one inside this triangle though? So this A or EBD angle right here doesn't help me. So it turns out those parallel lines only give me this one pair of angles. You need two for the angle, so these are not similar. At least I don't have enough information to prove they're similar. They might be similar, but I don't have enough information. So not enough information, can't do it. Anything else? Yeah. 8. The big thing we need to realize about 8 is we have a small triangle right here. And we also have this large triangle here. Maybe what I could do is I could draw that large triangle down here so you can see it a little better. So I have J, L, N. Some information about JLN is this 10 plus this 4 equals 14, so this side is actually 14. The other side they have here says that this is 21. Hold on, if this whole length is 21 and this little chunk here is 6, that should make LK 15 because you need to have the 15 plus the 6 to equal 21. So I'm going to go back to there and I'm going to list this as 15. Now the other thing I want to note is these two triangles share this angle L. If I draw this small triangle, I draw angle L the same way I would draw angle L here. So we could immediately put our little dirt marks here and here if we rewrote it, which means we might just have to have side angle side. That's what I'm looking for. Side angle side, there's an angle. That means my sides must be proportional. That means long to long equals short to short. So I look at the two triangles, I look at that small purple one, and I'm like, oh, 15 is bigger than 10. So 15 might be the one I put a box around. Maybe 10 I circle. For the other one, 21 is bigger than 14, so I'll circle 21. I'll box 21, I'll circle 14. Big to big over small to small, I'll do 15 over 21. Must equal that 10 over 14. And then the only question is that a true statement? Does 15 over 21 equal 10 over 14? Yeah, that turns out is true. If you do the math, that's true. And so we'd have side, angle, side. Once again, you'd need a triangle statement. Well, I should put side, angle, side similarity. We should have triangle something, something, something is similar to triangle something, something, something. That is what the direction said. It is on my answer key. Yeah. Mm-hmm. 14 says given measure of angle QPT equals 42 degrees. So QPT is 42 and PR bisects QPT as well. Okay, so they tell me this whole measure QPT is 42 degrees. I was going to put a little arrow and say that's 42 degrees. But then they say that PR is an angle bisector. What does that mean about both of these small angles then? They're both going to be 21. Yeah, so we'll have 21 degrees in both of these. Now, in order for these triangles to be congruent, they must have... Oh, Jesus. Your water is everywhere. Oh, it's not in your backpack, so we're good. All right, that means I should probably find these missing angles because I do have a 21 and a 21 that are congruent. How do I find this missing angle here?
Adding up 58, 21, and then subtracting it from 180.
Yeah, so we just have to do 180. So this right here is 180 degrees minus the two angles that we had known. And what's that going to equal?
101.
101. Does 101 equal 102?
No.
No, these are not similar. But you still have to go through this work because the one on the quiz might happen to be 102 and not 101 this time. So make sure you understand those steps. So since that's 101 and the other one's 102, those are not similar. But you have to do the work. You have to know what an angle bisector is, and you have to know how to find the missing angle of a triangle. Anything else? Okay, so what we did forever ago is basically what we're going to do today, except for this time we have to put it in proof form. So we actually have to say things like, oh, these are vertical angles, so they're congruent. Or we have to say that they are, in fact, proportional sides. So we're just doing exactly what we did, but we're putting it in proof form. So rather than just being able to draw on our drawing, we have to then support what we did. So if you understood what we did on that homework, this shouldn't be that bad. We just have to add the support to the right-hand side. So we're going to go ahead and we're going to do a proof. We're going to prove that those two triangles are, in fact, similar. And if we look at this, they're talking about the big triangle here. Is similar to that little triangle here. So I got red to purple. Got to prove that those are similar. Well, they do have a given. If you're not getting the given right on the test, I don't know what's happening in class. All we have to do is write what it says. MN is parallel to JL, and that is my given. So maybe I'll come up here and I'll draw my parallel lines. What am I probably looking for if I give you parallel lines?
Angles.
I'm probably looking for angles. In fact, does it say anything about sides? Does it say any side lengths on there? No. So the only one that doesn't use side lengths is angle. So I need to show somehow that two angles between those two triangles are in fact congruent. Does anyone see at least an angle that must be congruent between the two triangles because they're parallel? Safety? K. Ooh, that's a really good one. That's a really easy one because why is K congruent to K between those two triangles? What was that? They're on both triangles. Now, what reason do we give, though? So, number 2, I could say angle K is congruent to angle K. Why? It's reflexive. It is the same angle. It's a reflection of itself. It is our reflexive property, so it's just reflexive. I need another angle. I either need an angle or two sides. It seems like it'd be easier to get an angle than two sides, particularly because they gave me parallel lines. Think about it. What is my next angle that I could show is congruent between those two triangles? Yeah.
Angle KNM and KLG.
Yeah. So what Zavar just brought up is this angle here and this angle here. What kind of angles are these compared to these parallel lines? Those are corresponding angles. And it was perfect. We cannot call this one N. You can't call it N because there's a bunch of angle N's. So this one has to be labeled as KNM. So we're going to go ahead and we're going to say angle KNM is congruent to this one. If I say look at angle L, are we all looking at the exact same angle?
No. Oh, yes.
Yeah, more than likely we're all looking at angle L because we don't go the long way around. But so we could use angle L. I'm going to go ahead and I'm going to go with the 3 letters because 3 letters always works. 1 letter only sometimes works. So I'll use all 3 letters, KLJ. And you said that was corresponding angles, right? Corresponding angle. Is that the converse? Is it the converse that goes from parallel lines to them being congruent, or is the converse the one that proves they're parallel? Oh, the converse proves they're parallel, so this would be the corresponding angle postulate. So you can still use your postulate and theorem sheets on this quiz. It just won't have any of the angle, side, or side similarity statements. How many angles did I show were congruent between those two triangles? Two. How many do I need? Just two, right? Ooh. Is this angle similarity, or is it just angle? So we just need two. So we could go ahead and say we're done. We can go triangle JKL is similar to triangle MKN by the angle similarity. Do not just put angle. Make sure you put your similarity mark after it. If I had to show three angles were congruent, could we have done it? Yes. What's J and KMN in comparison to each other with parallel lines? Corresponding angles. Did I have to use the reflexive property? No, we could have also just used two corresponding angles. So this one had a couple different ways because you could show all three of them are in fact congruent. But don't go too far. Just get the two and get out. Questions on that proof? We sound a bit rusty. Parallel lines, you're looking for alternate interior angle or corresponding angles. That's it. If you're on a test, make a guess at it. All right? Know that we're trying to show angles are congruent. If I show parallel lines, at least there's one angle that's congruent because of those. We're not really doing the same side interior because we're not talking about 180. We're talking about things being congruent. So get that in your cabeza. All right, our next one says WY bisects angle XYZ, and it also says that XY over ZY equals YWY over VY. Okay, so we have proportions. We have sides being proportioned. Let's just start at WY bisects angle XYZ. That's my given. What I want you to do right now is do the next step. What does this mean? You should all have the exact same next step right now. So write that given, and then write the next step. If you are not sure what the next step is, ask your partner, or at least check with your partner to see if they're coming up with the exact same second step. You and your partner should have the exact same second step. Kane, if you want to, you can turn around and see if they have like the same idea. Working on your second step. What do you got? Make sure you're putting angle before the three letters, because three letters are meaningless unless you put the angle before it.
Is that right there?
I think so. We can look at it. Did you check with your partner? Do you guys both have this line over it? Do you guys both have these lines over it?
Yeah.
Do you guys both have the same answer?
Yeah, I don't think so.
All right. What should my second reason be? It should be definition of angle bisector. Definition of angle bisector. Does an angle bisector create a midpoint on a segment? No. So should we have any segments named? No. What is an angle? Can someone describe to me what an angle bisector does? Yeah.
It splits an angle in two.
It splits an angle in two, so I should be talking about two angles, right? So if I say midpoint, you should list two segments. If I say angle bisector, you better be listing two angles. So if I look at what's happening, we are bisecting angle XYZ. So if I look at XYZ, I'm looking at this. And if YW is an angle bisector, it cuts it in half. That should be on your picture. That this cuts this angle in half. Now I just have to name these angles. Can I name this angle Y as congruent to angle Y? No, don't do that. Don't do that. You need three letters to say this particular angle here. This mark right here is XYW. This mark right here is VYZ. So your next one should be naming two angles. I picked XYZ. You could have did XYW. You could do WYX as well. As long as Y is your vertex, has to be in the middle. So we'll go angle XYW is congruent to angle WYZ. All right, I used that given and I got an angle. That means it's probably going to be side angle, side, or angle, angle. Well, they don't give me any more information about angles, but they do tell me that XY over ZY equals WY over VY. Now, it doesn't say they're congruent, but even though they don't say it's congruent, you could put like circles and boxes to make sure that we're doing sides from each triangle. So if I look at XY over ZY, XY over ZY, I could put a little box by both of those to say I'm comparing that side to that side. And then it talks about WY, VY. So WY is this whole orange side, and VY is this side right here. So I am comparing a side, angle, side, and for the other one, it's a side, angle, side. So that given gives me my sides. Step 3 is given, and then we're done because that is side, angle, side. So my step 4 is we are done. So the only work you had to do is understand that what an angle bisector is. And you have sheets that say what an angle bisector. It gets a little frustrating when I see on tests where people are like, oh, angle bisector means that it creates a midpoint. I gave you sheets that actually tell you what an angle bisector is. You have sheets that literally say what it is that you can bring into a test and a quiz. We should not say angle bisector creates a midpoint. You have sheets that specifically say it cuts an angle in half. All right, our very last one. We have parallel lines, and we have these two statements after them. Let's do the parallel lines first. They tell me PR is parallel to ST. That is given. So PR and ST, let's highlight those two lines. Now, when I give you parallel lines, you are looking for two congruent angles. So I gave you two parallel lines, PR, ST. And I spelled given without an N. Weird. There we go. Wrong color. I give you parallel lines. Your next step is probably giving me congruent angles for this section. Do you see two congruent angles that are formed by those parallel lines? Take a second look.
P and T.
Shh. Take a look. Joseph?
P and S.
P and S, and I got P and T. I got two different ones.
Well, wouldn't it be P and S because like corresponding angles?
I don't think P and S would be corresponding angles because let's highlight the transversal. Remember, the transversal is a line that connects the two lines. Notice how that doesn't even touch S?
Yes, it'd be P and T.
It would have to be P and T because this is the only line that connects those two. We don't have to look at S because that line doesn't connect to those two things. So I look at that purple line, that's my transversal, that's P is congruent to T. Angle P is congruent to angle T. Now I can say that because there's no other angles. I don't need to use three letters there, but if you want to, you can. All right, and that is going to be my corresponding angle postulate. Right? Are we okay with it being corresponding angle postulate? Alternate interior angles would be a much better correct answer. Are these both on the interior? Are they between the two lines? Yes, so those can't be corresponding angles. They must be alternate interior angles. Those would be alternate interior angles. I told you those could be pretty much the only two that we're going to use in the triangle section are either corresponding angles or alternate interior angles. If you're on a test, you can take a guess if you're not sure. But the easy way is, are they between the two parallel lines? Yes. Are they on opposite sides? Yes. Corresponding angles are actually on the same side of the transversal. Just one's on the interior, one's on the exterior. All right, cool. Well, this is looking a lot like this one, that they give me information to prove an angle. I have an angle. That's the only information they give me because I can't get any more angles from that. So that must mean that those other two statements somehow show that we have sides being proportional. So let's go ahead and write the next given. Our next given is UT equals 2PQ. And they also give me ST equals 2PR. That is my given. All right, UT equals 2 PQs. ST equals 2 PRs. Let's just look at that and see if we could at least describe what's happening here. Now, remember, to be proportional, picture if I have like a scale factor. If I say, I don't know, if you build models like a car is 1/20th the size of an actual car, that means every piece is 1/20th an actual. It's 20 times smaller. So let's look at UT. UT is this line right here. In fact, I'm going to put a circle by that. Or maybe a box. Let's put a box by that. So they're talking about UT. UT is my box, is 2 times PQ. So if I take PQ and multiply by 2, I get this length here. Okay, then the next thing says ST. Let's put a circle by ST. And then they compare it to PR. And they say if I have 2 PRs, it equals ST. What they're saying is, if I take any side from this triangle, or if I take this circle, multiply by 2, I get this length. If I take this box, multiply by 2, I get this length. So what they're telling you is this triangle is 2 times the size. That is proportional. That is, in fact, proportional. That this times 2 would equal that bigger one. So holistically, this should be proportional. Make sure I didn't miss anything along the way. I haven't been looking at this at all. Okay, so we're multiplying by 2, so 2 is going to be our scale factor. So in fact, right now is our time to show that these sides equal a particular scale factor. What I'm going to do in step 4 is say that 2 is my scale factor by doing something like this. I'm going to say UT over PQ equals 2. I'm saying that those two sides divided equal my scale factor of 2. How in the world did I get from this statement to that statement? And don't overthink this. This is one of the first property things we ever did. Yeah, Joseph.
Divided PQ from both sides.
I divided from both sides. What allows me to divide something from both sides? Division POE, property of equality. It's on your very first sheet of your things, which you have. Well, I could do the same thing for the other one. So I'm going to go ahead and put a comma here and say I would have ST divided by PR equals 2. That's also the division property of equality. So I have both of those equal a scale factor. Now I can say both of these equal each other because we can use substitution. I can use substitution into ST, PR, and I can actually substitute it in for this 2 here. So I can use substitution to say, step 5, UT over PQ equals ST over PR. That would be substitution. And you are now done. I have side, angle, side. I proved two sides are proportional, that we're flanking that angle. So our end answer is going to be those two triangles are in fact congruent. Or not congruent, but similar. So WXY is similar to triangle ZY?
Yeah.
And that's going to be by side, angle, side. All right, the rest is homework. I think, what do I have? I have 7 proofs. They are varying levels of difficulty. Sometimes I just kind of give you the information. In fact, I'm looking at 1, 2, 3. 1, I give you parallel lines. You should also see vertical angles. So I'm basically giving you 2 angles. The next one, I'm giving you sides. You should see vertical angles. So I'm giving you sides and angles. 3 might be a little bit more difficult. I do give you an angle from the drawing. 4, we're looking at parallel lines. Parallel lines should give us an angle. Number 5 is kind of like the one we just did. 5 is like the one we just did where we need to create out that scale factor between everything. 6, not so bad. I can see I have vertical angles. 7, not so bad either. So I didn't give any really difficult ones on there.